We talked about it a little bit last week, but it's in the optics unit as well. And so I want to go ahead and go over it in the today, just so you guys, are getting it both in case you didn't go to both. Okay, so this right here is going to be my mirrored surface, my flat mirror surface. And then, so sorry. I really hate coughing. So now I'm going to draw the normal. And the normal is a perpendicular line to your mirrored surface or to whatever surface is doing the reflection. Okay, so this should be like a 90-degree angle. If it's not exactly, it's supposed to be. Okay, and this is called your normal. Okay, and so a lot of times they'll say like to the normal or whatever. I saw some test questions today that were talking about reflection and refraction in the optics unit, and they were mentioning the normal. So it's important that you know what that is. Okay, now the law of reflection is pretty simple. It basically says that whatever angle that this is called your angle of incidence. Okay, so I'm going to write that. It's your angle of incidence. And it basically says that your angle of reflection is the same as your angle of incidence, so they equal each other. Okay, so there's my angle of incidence, and now I'll try and do my angle of refraction. Let's see if I can get a different color. Okay, that's not going to be exactly right. Okay, well, I'm trying to start here. That's probably as good as I'm going to get. Excuse me. It says our angle of incidence is equal to our angle of reflection. And this is our angle of reflection. Okay, and that's all it says. So they're just exactly the same. Okay, if this is 35 degrees, then this is going to be 35 degrees. And the way you would say this is 35 degrees to the normal. Okay, if you wanted to use this angle, you would say, what's 90 minus 35? Let me do the math. Sometimes I'm not good at doing that kind of math in my head. And by sometimes I mean all the time. Okay, 55 degrees. If we wanted to say this angle, we would say 55 degrees to the mirror surface, or we would say 35 degrees to the normal. So it's important, right? Because 55 degrees to the mirror surface is not the same as 55 degrees to the normal. Okay, so it's important that you're, are saying the right one. Okay. So that's the law of reflection. Again, we talked about it in the second part of the electromagnetic waves review, but it's popping up again, so I wanted to show it to you. Now let's talk about specular reflection. Specular reflection occurs on a smooth surface. And then on your test, they actually called it regular reflection, which I don't know how they decided what was regular and what was diffuse. But they call it regular reflection, but the actual term is specular. And so let's think of some smooth surfaces that are considered that would have specular reflection. Your phone screen, shiny. Your any mirror would have a specular reflection. A shiny car, like a real nice and clean shiny car, Sometimes the ocean surface, when it's really, really flat, and you get that light that kind of shines up and almost blinds you, um, that would be specular reflection. So it has to be something like real shiny that will give you that kind of reflection that kind of almost blinds you. Um, for example, a lot of times when my husband's driving and I'm playing on my phone in the car, because that's what I do, he'll say, "Can you tilt your phone away because it's the reflection is getting in my eyes." Okay, that's a specular reflection that's getting in his eyes. Okay, because you've got that nice smooth surface and the reflection's coming in and going out, and all the light waves are acting the same. Okay, diffuse reflection is going to happen on a rough surface. And to me, this feels like regular reflection because, these seem like special cases where everything else is diffuse, but I actually saw in the test they called specular regular. So I just wanted, to keep that clear for you guys. So like concrete, um, uh, concrete's a good example. Um, anything that's not smooth, basically. Okay, so what happens with this diffuse reflection is you've got this rough surface. Okay, excuse me. The law of reflection will still apply, right? So you're still going to have this one's coming in at this angle and coming out. But then, you've got this angle here and it's coming in here and going out here. And it's coming in here, going out here. So because you've got all these different angles and things, because it's not totally flat, your light kind of gets scattered. And so that's why they call it diffuse. Okay. So, and again, we kind of talked about this a little bit in the part 2 of the EM wave review, but just in case you didn't have that